All right, schedule for the last couple of weeks of class. We have an exam this Friday, study guide is posted. Then next week, Wednesday, we have homework 6 due and CYK due. I am probably able to push back LL parse some from there. I know that that is the more challenging of the projects. So the goal would be to make sure that you can get everything in and not make 3 things due on the same day. So that seems reasonable. I'll talk to the grader to be absolutely sure of it, but we'll see what we can do, and I'm quite sure we can make that happen. Then we have the final either a week from Friday or the following Monday, depending on, I will be here both days for that, and you can take that when you would prefer, when it works better for your schedule.
Could we come for the like prescribed final time, or is it just gonna be?
It would be, yeah, the prescribed final time, and then you'll have 2 hours regardless of which time you choose, even though I'm designing it to be an hour, but up to 2 hours for that.
It's kind of like if you show up Friday, you take it then, if you show up Monday, you take it then.
Yeah, it'll be, other than that, a pretty identical experience.
So we'll have like we can just either Friday or Monday, because some of us do have our capstone final presentation that we'll have to do.
Yeah. I assume that that period of time is going to be hectic and busy for everyone. So if I can build a little flexibility into that, I want to. All right. Any questions on schedule before we dive back into practice problems for Friday's exam? Yeah.
You know when like exam 2, homework 4 and 5 are gonna be in?
Exam 2, I can try to get in today. I just have to get them in. I'll have to talk to Dominic. I actually was looking for him this morning. I will try to catch him after class to get a sense of when those are going to be graded, but I would like them to be graded before the last exam that utilizes that content. So I'll apply some pressure. Other questions?
Is there, I think last time you said that you would post these practice problems. Have you had a chance to do that?
I should do that. In fact, I can do that right now. Let's do that before we go. I guess I'll do that while we start our first problem. You can see it right there, but it's designing a Turing machine to add 1 to a binary number. And again, I think it would be better for you to try to do this on a single tape. Doing it on 2 tapes would be a little bit easier. Maybe design a 2-tape solution and then convert it into a 1-tape solution. But getting something on 1 tape would be a little bit more challenging. Maybe you learn a little bit more from it.
Is this just, oh wait, it's not saying like add a 1 to a binary string, it's add 1.
Yes, to a binary number. So if you get the number 111, then the ending result should be 1000.
Okay, let's see.
Assume that it's positive, not 2's complement. There's no such thing as a negative binary number. Whatever number's on the tape is the number.
Are you gonna go over the answer for all of them at the end, or?
We did the answer for the first one in the last class, but we'll do this for this one. My goal is to take my time with these since we have a little bit more time. So I'll make sure that most people to everyone has a solution to this, and then we'll do what we did last time, get some people to come up, draw their solutions on the board and talk about it. So in the meantime, I'm going to get up these practice problems.
You said you wanted this one to be a 1-tape Turing machine?
Yeah, just for the practice. On an exam, I will let you use any equivalent Turing machine that you would like to use. So you can do that too as well. Like, That's excellent. How are other people doing? Multiple people have an answer? Awesome. Anyone want to come up and draw their answer on the board? Yeah. I think I have every color actually with ink now. What color do we want?
Let's do green. And let's do the black.
If you don't have yours working yet, feel free to keep working. Also, I took a look at the calendar and I think it is reasonable. I extended CYK from Friday to Monday. And I extended LL from Friday to the following Wednesday, just to try to give people a little bit more time. I don't want it to affect things like the rest of your final schedule, but I think more flexibility is better than less.
So is CYK due a week from today?
It's 2 weeks from today. It's
Because next week's dead week, right?
next week is the last week of instruction, followed by finals week. So it would technically be dead week, but we still have class.
Yeah. But so then it's due that Monday.
I think it's 2 weeks.
So LL and CYK are due next Monday, not like this upcoming Monday.
Yeah, it's the following one. I'll draw the full calendar up on the board.
Can you make it in a Turing machine?
I can appreciate that.
Yeah, you can use stay doesn't change the power, so you can, I think you can use anything to talk about in class. Yeah, right.
In class. But what if you read it blank from Q2 to the Q1 and Q2?
Yeah.
Blank.
We go back left. I guess, so if you hit the blank, then. Yeah, exactly. Because
I just added a blank, but I don't know what to do with it.
I see.
When you go back, social mixes in your house.
Yeah.
If I hit blank. Yeah, if I hit a blank, I should write a blank too.
Kind of like just putting out like the very first one.
Yeah, because that would be, you carry everything up to the next, like, the next one.
Okay. I'm assuming Q1 left on the transition one just to go back into that last position of November.
Yeah, because we go all the way to the end, yes, we want to go backward, and so we're at that first, like, all the way to the primary.
Now,
And then we left, two or three rows to the rows, to be hit.
It has to only stop.
Or the end, like you said, and then we put back to the one. That's what. Yeah, I can see, it's like. I think that's what they said too, it's like similar transition. So like whatever combinations.
Yeah. I realized I could probably simplify mine.
That makes sense, actually.
Irrevocable state. Or. Yeah, I really.
Do you want to make the change?
No, I'll
Make
just
the
leave it
change
up
or leave
there.
it?
I'll just leave it up there. It carried, it cleans it up or something.
So here's an updated calendar in a bit more visual form, where we have exam 3 this Friday, homework 6 next Monday, first chance for exam 4, week from Friday. Then we're into finals week, where this is your second option for exam 4. This is the day CYK is due. So it's just about 2 weeks from today, 2 weeks from yesterday, and then 2 weeks from tomorrow for LL. I think that'll give people enough time to hopefully work that into the rest of your end of quarter obligations. Any concerns with that schedule? Anything that I can improve for some people's schedules that I might be able to advocate for with the grader, with my own schedule? Make it work. I think that's perfectly reasonable. The grading deadline's not until the following week. So I think, especially having homework 6, the homework is the biggest time consuming part of it. Having that due first will let me space the other ones out. So this seems fair to my grader. So we will do that. I've made changes to the associated deadlines on Canvas. I've revealed everything on Canvas. But anytime there's something missing that you would like on Canvas, reach out to me. I try to get those changes done as soon as I can. All right, anyone want to talk about their solution?
I'll talk about mine.
Yeah, one and Adam, and then, yeah, 1, 2, 1.
It looks like we have like the same one there, but like, yeah, so you start with state Q0 and then you're gonna move all the way to the right. So like, you're gonna be looking for a blank. So you skip over every 0, leave it 0. Skip over every 1, you leave it 1. When you hit that blank, you go into state Q1, and that state means that you're gonna be adding your 1. You shift left. So, and then if you run into a 1, change it to a 0. And you're gonna keep carrying over the 1 until you find a 0 position. You change that to 1, and you go to the final state, and you stop.
Okay, seems perfectly reasonable. Yeah,
Mine was the same thing. Riley brought up the idea, like, if you had all 1s, so then you would have to, have that final transition with the blank where you add a new 1 to the end.
yeah. So we're moving all the way to the right until we hit a blank, moving back left. Then, yeah, we see a 1, we change it to a 0. And then as soon as we find that first 0, we turn that into a 1.
Or if it's all 1s.
If it's all
then get
1s,
0,
yeah, then you
add-
eventually get to a blank, then you add a 1 from there. Seems reasonable. Can anyone think of a counterexample to that? A particular binary number where that does not work? Is this process any easier with a second tape?
Not really.
Not really?
One tape is pretty good person.
Yeah. I think this makes a lot of sense for a 1 tape Turing machine. There's not a ton of, you can carry everything you need with you based just on the state, on a single pass, right to left. Over the number. What were you thinking was what was your thought process as you constructed this, Simon, and what did you notice about something that you could simplify?
So something, the thing I realized looking between comparing myself to what their answers is that like, I had an extra state, and the reason why is because I thought I needed one for the carryover, because like, obviously, like, if there's a 1, you set it to 0, and that's what state 2 is for, is to account for the carryover, and that.
Right.
And I realize that it's needless, because I could technically just have that in with like the add 1, just add 1 function, just loop in on itself until we find a correct output.
Yeah.
Cause like, I don't think it's anything wrong, it's just I could really chop away that second or that extra state.
Yeah. Any of these on an exam would be worthy of full credit. It does not need to be hyper optimized, minimal number of states. As long as the logic is there, that's all I care about. Let's get people started on the next thing. Unless there are any other questions before we do next problem? All right, on to a context-free pumping lemma. So this is A to the I, B to the J, C to the I, D to the J. Show that that is not context free. I think this would be even better if it were worded as a show that this is either context free or not context free. I'm giving away a lot by saying that it's not context free, because I think that would have been a good challenge for some people to determine why can't a stack handle that. But start there, think about that, come up with some reason why a stack wouldn't be able to handle this logic. And that may help you to construct the pumping lemma proof.
After you've iterated through A and B, all the stack memory is gone, so there's no guaranteeing that I equals I.
Right.
Okay.
Yep.
Yeah.
Yeah, because you basically need to map this to that and this to that. And you could easily do that if it were something like A to the I, B to the J, C to the J, D to the I, because then you could push the A's on the stack, the B's on the stack, map the B's to the C's, map the D's to the A's. But now there's no way to do that, because what you want when you have access to the C's is at the bottom of the stack. If you had a Q here, you'd be just fine. But we don't have a Q, we have a stack.
Yeah, it's just figuring out how to write that.
Yeah. Feel free to just start working up there if you'd like. Anyone else want to do their work on the board rather than on paper, then convert it to a board? Otherwise, you can do the work on paper and then convert it to the board.
Can I ask, if I like, I think, if I like create a situation where like. Sorry.
Yeah.
Like a pump A's, can I say like there are more A's than C's and that can happen or something like that? Or-
Sure. If the string that you select as your, if those have the same number of A's as C's, which is necessary to do, then if that's if VXY is over all A's, then if you pump up, you know that you're adding at least one A. So we're no longer mapping the number of A's to the number of C's.
think about it, it's. A and C are supposed to be together, so.
Great. For all of the other cases,
Yeah.
there are a lot.
Yes. Two.
I have a question.
Yeah.
So for case. 3, I said it's the A's and the B's together,
Mhm.
and I explained why. And then for case 4, it's B's and C's, and case 5, it's C's and D's, I just said similar thought process to case 3.
Can you prove it for one and just say like also applies to? Like,
Yeah, you
that's
can
the same
group
question.
the cases if it's a similar approach, especially on an exam. I will be able to draw that conclusion. Grader could draw that conclusion, knowing that. If something with this many cases were to show up, you would probably want to be grouping as many of them together as possible.
In terms of like the pre-setup where it's like suppose whatever is a CFG, blah, 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 is that enough for it, or do you want? Or is it just mainly like proving why the cases work is like what you're looking for?
And on an exam, that would be mostly what I am looking for, but. The setup would be important enough that there's enough there.
As long as like the strain.
Yeah, so having the assumption there is important. Writing that it can be decomposed in such a way that all of that is important, but it doesn't need to be longer than it needs to be. State it, don't overstate it. That one and or these.
Is there gonna be a situation where somehow I'm gonna have to make it less than 0 or something like that, or is it just like? 'Cause I feel like the way to answer this is just say that, like. The two numbers won't match up basically.
Yeah, you actually, since I needs to equal I and J needs to equal J, any pump of any kind will work for any case. There aren't really too many tricks to this. It's just identifying the cases and then explaining.
So I'm trying to think about it for like the situation where it's like some A's or B's, for example.
Yeah,
I'm wondering if like A's and B's, since they're like, it's the same thing of like, if I pump just A, then there'll be more A's than C's when they should be the same. Or
yes,
A and B, it's the same thing, but with two variables where there's now more A's and B's than C's and D's, they should be the same.
right.
Okay.
Yep, that's exactly, that will work.
Hmm.
Okay. We're going to have how many total cases for this?
Yes.
4,
7, 9.
I get 7 total cases.
Would it include like only A's, only B's, only C's, and D's, because that's the one I did.
Yep, and then it would include some A's, some B's, that overlap of some A's and some B's, some B's and some C's and some D's. And then those are gonna break down into 3 cases, because we don't know where the B and the Y are within those. If the V or the Y overlaps the A's and the B's, then it breaks the structure of the language. And if B is all A's and Y is all B's, then we can pump those up in such a way that it mismatches the C's and D's.
See.
Yeah, we need all of those cases.
Include this in the answer as well.
So then, like when we're writing this, pumping them, can we just do like case 1 and then just do where, VXY is all one?
All A's, sure. Oh, you mean just all one character in general?
So I could just like,
If you broke this down into something like the first half is A to the I, B to the J, the second half is C to the I, D to the J. Then what we need to do is map the first part of the first half with the first part of the second half, the first part of the second half second part of the first half, second part of the second half. We need to map the I's to I's and the J's to the J's. If you can outline that and say, if you pump up one of those, then it's going to mismatch the other. Then that's probably good enough, as long as you set up the, here's the notation that I am using, because it's really easy to fall into vague wording if you do something like that, and then I don't know if you know what you're talking. So as long as the wording is structured such that either you're using variables or you're very specific about the wording of how you're breaking apart the string and referring to it, to make sure that that is
So
clear.
like, if I did a case like this, BXY is all B's and C's.
I would, yeah, consists of all B's and C's. Then that would break down into the cases of, there are really 5 cases, but 2 of those cases condense to other cases that we've considered. If V is empty and Y is all B's, then that's the all B's case. So the only 3 new cases we have is V overlaps at least one A and at least one B, Y overlaps at least one A and at least one B, and B is all A's and Y is all B's. Those are the 3 new cases for A's and B's. If there's any overlap, B is A's and B's, Y is A's and B's, then it breaks the form of the language, as well as the number of. So you could just group all of that together and just say, we're still adding at least one A or at least one B. Therefore, either there will be more A's than C's, there will be more B's than D's, or both, and none of those are in the language.
That would be so crazy without PowerPoint.
While we're constructing our string W, should it be that it's kind of like Zach's, but because I and J don't have to be the same, should you instantiate a different?
A different P for that, you could, it actually in this case doesn't matter, nothing in this says that I and J are distinct. And your point will still stand, whether you use the same I as J or a different one.
Right.
It's just a matter of how you word it from there. If you're trying to refer to the first half of the first, there we go. The first half of the second part, then if it's the same one, then you might be referring to the same variable, and now it's harder to verbalize that.
Well,
So you may want to use something like,
because they can't be the same, because they're the case where like, say BXY goes from A into the C's.
only if you did something like A to the P over 2, B to the P over 2, C to the P over 2. So you don't want anything that is less than P, because then you could create yourself additional cases that way. But the only rule is that you have to generate a string that is in the language that is of length at least P. So you could reasonably pick A to the P over 4, B to the P over 4, but then that would create the case A's, B's, and C's, the case B's, C's, and D's. And now it gets really tricky to start to show. And in fact, the entire proof may break down at that point. If you have the over 4, then there's the A's, B's, C's, and D's case, which will not work.
I'm sure if I was correct, pumping down on this one, case 5, BXY is all B's and C's.
No, that'll still work. You just have to say that there are now fewer B's than D's or fewer C's than A's. Or both.
There will be fewer C's
Than A's
or
or B's than D's or both.
finally.
So on the right here, we have the 2 generic types of cases. Either they're all the same character or they're between. So if the So what this is missing is a setup, but I'm kind of just assuming that this has a similar setup to red. And if that were the case, then breaking them down, it doesn't really matter whether we choose the A's, the B's, the C's, or the D's, as long as we can create the pairings of A's are paired with C's and B's are paired with D's. If we're making a change to any of them, then when you set I equal to 2 and pump it, we get UVV X, Y, Y, Z, which means that you add the length of Vy to either the A's, which creates a mismatch with the C's, the B's, which creates a mismatch with the D's, the C's, which creates a mismatch with the A's, or the D's, which creates a mismatch with the B's.
On the test, would you prefer the setup there with like the BXY less than all the things he has up there and stuff like that? Would you prefer that?
That would be either necessary to show the contradiction, because if you just say contradiction, what is it, what are we showing that the, or showing that your setup is something that is legal, be able to show that we know that the length of W has to be greater than or equal to P, so that we've adhered to all of the constraints with our selections, because I know what those constraints are. That helps me to know that you picked a string, not because it was a guess, but because it adhered to all of those constraints.
The other reason I did that is because I figured we were all reading the book, so I just left it out, but.
You're probably one of 3. Maybe that's not the case, but
With yours, you kind of condensed what I did for cases 1 through 4. I just did it individually.
it works as long as there's an explanation for that. You would have to break this down into saying that if you pump the A's, mismatch with the C's, pump the B's, mismatch with the D's, etc. I think that is a little bit missing from this, but the idea is very right.
Oh, for his or?
Yeah, for yours.
It just kind of goes through all the different ones, which.
So one thing that I like about the green over the red is having an actual expression that shows that mismatch. So when you say means more A's than C's, that's kind of a vague wording that I have to really, if I'm a mathematician and I'm not doing this every day for homework, and I'm looking at that saying, why? What does that mean? Having an expression for that actually shows that now there are more than MAs, because especially what's missing from the green is that the length of Vy here has to be greater than or equal to 1. So if this could be 0, then it wouldn't necessarily be a contradiction with the language. But having that constraint on the board, you can now map this expression to, oh, we're adding at least 1A here, duh, now it's a contradiction.
So something like this.
Yeah.
Okay.
And you don't necessarily have to show it for every one. If you can find a way of roping it in to say whichever letter we are currently pumping, this plus the length of Vy is on that exponent.
All right.
That is plenty good enough.
All right.
I know it's a lot. These problems require a lot of writing and a lot of time, especially the context-free pumping lemma questions.
Okay, I mean, I know that,
Yeah.
I guess it probably helps on the test to like cover that intersection method and stuff like that, but is there any way that if you have one that wants us to do the intersection thing, determine if it's context free? Could you also have one that just tells us it is, so we can just launch into doing the pumping lemma thing?
Yeah, not have to worry about that. This is why I did this here, is because I will do that on the exam. I'm not gonna have you spend that much time followed by that much writing if it is a context-free pumping lemma, because that's way too much of a 1-hour exam. I would much rather have you show that you know how to do it rather than interpret it. But I think there is an important outcome outside of an exam of being able to do that interpretation. So the question I have for people, I guess we should start with questions on either of these solutions. Any of how to tackle this, how to work through it on an exam. There's one more important question that I want to pose related to this that is not immediately here, but I think is important. So now I'm going to say that the language is context-free, but we're going to make the change from using a queue to using a stack. So if this language were A to the I, B to the J, C to the J, D to the I, if you launched into a context-free pumping lemma, where would this break down? Where would you fail to find the contradiction? Exactly right. But I want everyone to see that as well, because if you were tasked with doing something like, is this context free? And you start down the path of a context free pumping lemma and it ends up, how would you be able to identify that I shouldn't be using the context free pumping lemma because this is context free?
I don't know if I necessarily know that second part of your question, but when you get to the B and C, you don't know how the VXY breaks down.
Yes,
So you don't know if there's more in the V section or the Y section, so you don't.
and if it happens to be equal,
Yeah.
then it's an issue. Yeah, so every other case will work. You'll be able to prove it, prove it, prove it, prove it, and this is why we can't just stop with some subset of these cases, because it is the B's and C's case where if we're gonna break this down, we end up with some B's, we end up with some C's, and again, I'm assuming this is a reasonably long string just to show this. But imagine that V comes up here, X comes up here, and Y comes up here in some way, shape, or form, where the length of B is the same as the length of Y, and B is all B's and Y is all C's. And again, assume that maybe there's some more B's out here, because remember the length of BXY has to be less than or equal to P or M. So if this was A to the M, then this entire length would have to be at least 6 A's, B's, C's, and D's. So just assume that this goes on for a while. But if this were VXY, then what do you pump for VY? If you do UVVXYYZ, you're adding 2 B's and you're adding 2 C's. If you add, you get A to the I, B to the J plus 2, C to the J plus 2, D to the I, that's in the language. In fact, there's no level of pump to this, up or down, that would be a contradiction. You would always be adding the same amount to the J's or removing the same amount to the J's in a way that you can't produce a string that's not in the language.
So technically though, like, because there can be so many grammars that represent a language, would it be more saying like the case is technically ambiguous? Because like you could have it where like maybe just V alone is the only thing producing values, so it's only producing B's. You can't know if you're proving it in generality.
Right.
Like,
Yeah. Yeah, it's saying that if there were a grammar in this form, then with some recursion that generates the same number of B's ahead and C's behind of that production would be legal and it would always produce something new in the language. So this is kind of it's possible to produce this grammar because if you design the grammar in such a way that you do this, and if you were to design a grammar for this, you would probably find some production, some non-terminal that had something like B capital A C with a recursion right back to the A that produced a B and a C for however many B's, and you just do this recursion J times. But something like this can't happen here because there's a different number of them between the A's and C's and the B's and D's in a way that you can't map to this kind of recursive grammar form. So that's the problem you run into. Every other case will work. Every other case will break, but that's the case, which is why we have to say for all. For all cases, there exists one counterexample, and this is the case where you cannot generate that counterexample.
Can you use that not being able to produce a counterexample to prove that it is context free?
Nope, because it is quite possible that no such grammar exists anyway, which is why we need the context free pumping lemma. It's unfortunate. It would be so nice if we could.
Can we do another one?
I don't have another one prepared, but I can by tomorrow.
Okay.
Any questions? Anyone need anything from the board before I erase it and go to the next thing? We can at least get you started with it.
It's just negative. Whatever the Y is. Sorry. Well, you have less. Language. You should be able to have a little bit. Are we supposed to be looking at this to
We probably won't have time to finish this one off, but
it's
this one is a non-deterministic Turing machine question. Identifying composite numbers. Remember that composite means not prime. Means it has some divisor other than one and itself. So there is some number written in unary, a bunch of ones on the tape, and your task is to accept if it is composite and reject if it is prime.
You only have to do like the square of that you only have to check so far, you know that it's composite.
Yes,
What is that? It's like the square root of.
that is an easy way. There is actually a. Yeah, so that's, I think there's an even faster way to do it, but the square root is probably as fast as we're gonna get. Of course, calculating that square root in a Turing machine is gonna be kind of fun.
Don't put it on.
That's why it's a practice problem.
Yeah.
These are actually a lot of questions that I designed that have either historically been on an exam or something that I've cut from an exam because I didn't like how it worked on the exam. A little bit too much. They become practice problems. So one, make sure you are thinking about using non-determinism, and two, this may be one where you really want to use multiple tapes. I would recommend against designing a one-tape Turing machine solution for the practice for this.
Unary again is like if there's 9, there's gonna be 9 ones, right?
Yeah,
Okay.
yeah, there's only one digit. Binary is zeros and ones, unary is just a single digit. Yep.
Like this.
Yeah, so from a particular state, there are 2 or more potential transitions that read the same characters or sequence of characters on multiple tapes. So non-deterministically, the way that I'm thinking of incorporating non-determinism into this problem is we need to go through a verifier, maybe the current number that we're checking in. Is this number divisible by 2? You could non-deterministically both write another tally on the second tape that says, now I'm going to check if this is divisible by 3, or launch into a verification algorithm that actually goes through and checks whether it's divisible by 2.
Like. And like the only thing we need to keep in mind here is that like it works if we can find something that like it can divide into.
Right.
So like I don't need to answer like if the number is 24, I don't need to answer like, oh, it works for 2, 3, and whatever. It just
Exactly.
It works for
As soon as you
2,
find 2, halt
then we call it.
and accept it's composite.
Is there a good way to do it if it's an odd number? No. Not necessarily.
Nothing easier than checking up to ideally the square root, but calculating the square root in a Turing machine is going to be kind of a pain. So maybe you go up to halfway or all the way. Is there something that's easier to validate on a tape?
Oh, I see. Oh, wait, yeah, I see how this like requires. How do you divide it?
What do you mean by the square root thing? I guess I don't know what you're talking about here.
So give me a query that maybe 16. I like nice powers of 2 for this. So if we're trying to find something that goes into it, you can imagine that it's prime if you could draw a rectangle only with side lengths 1 and 16. Are there any other possible side lengths that could create a rectangle? So we could do 2 and 8. I guess go halfway here. 2 and 8. And 4 and 4. I like to think of this visually because as soon as you get past 4, which is the square root of 16, you're creating a perfect square, and anything else would have to be the mirror of something that's longer vertically than horizontally of something that occurred before that. So there's no reason to check anything past the square root. You create the longest possible rectangle up to the perfect square. And then everything else would just mirror that.
1.6 and 10.
No.
I guess the one thing I'm trying to, I think I understand how I would add non-deterministic, so like one is obviously running through, checking every number, while the other. Like it's either running through a loop to check every number, and the other one is doing the division based on that given number. I guess the thing I'm trying to figure out is like, how do I do the division?
Yeah,
Like, cause it's just like, it's not like X number of ones that represent some number, it's like. What, like,
how did you solve that mod 5 problem on the homework?
oh, okay.
So seeing whether it's divisible by something would be saying, check if the mod of that number is 0.
The chapter 11 stuff, context sensitive languages and stuff like that.
Yeah,
Do you think those are gonna be more like multiple choice questions?
they would either be something like what is this? How is this used? Why is this class of language interesting? I'm not gonna have you solving, like generate a context sensitive grammar for, because we didn't spend enough time on it.
Presumably it would be the same for like recursively enumerable languages, since we didn't have like any actual problems.
Yeah, they would be mostly generate a type of problem that is recursively enumerable and walk through why it's recursively enumerable, or why is recursively enumerable? Why are there more languages that are recursively enumerable than recursive? Or high level questions like that. All right, well, we're basically out of time. Think about this between today and tomorrow if you'd like. Otherwise, we'll come back and work on this at the start of tomorrow. I'll go hunt down another context-free pumping lemma example, one that would be a good one for some practice. And the last thing we're going to be doing for practice problems is countable and uncountable sets.
Is tomorrow our last review day?
The last review day like this. Thursday is going to be a review day where I let you ask me the questions based on the study. Yeah,
Are all the slides for the study that posted?
yes, all slides are up.
You could look at.
Thanks, everyone. See you tomorrow.